This is Algebra 1, Lesson 6.3, Compound Inequalities. Goals we have today are to write, solve, and graph compound inequalities and attempt to explain them in real-life situations beginning on page 346. One definition to start everything. What is a compound inequality? It's two inequalities connected by words and or. Okay, so it's going to either have the word and or between two inequalities. Example number one is writing these inequalities based on the verbal description you get. A says all real numbers that are greater than or equal to -5 and less than -2. Now, most of the time, when you see the word and, there's going to be an overlapping area. And most of the time, when you see the word or, they'll be going in opposite directions. But sometimes when you see the word or, they'll overlap as well, like when we looked at the bell work a little while ago. So the first one says numbers that are greater than or equal to -5. Treat it as two separate inequalities. Greater than or equal to -5. Notice what we have for A. It's a colored in bubble and everything this direction. And, so there's definitely going to be an overlapping area in an and, less than -2. So it's an open bubble for that one, and less than is everything that direction. So that's what the graph is going to look like. When you write that, you write it, since it's and, anytime you have an and inequality, you write it with two symbols with the x in the middle. So you're going to use your two numbers, your two bordering numbers, -5, and then x, and then -2. And then you're just going to fill in the two blanks. Now, I know they're filled in already. I'm just explaining to you how to get to that point. Do it as two separate ones. The easier one out of the two to do is this one right here. It says x is something -2. And the reason that one's easier to do is because it's written the same direction that it's graphed. So look and see how it's graphed. It's graphed going this direction. So when you draw your symbol, it's going to go that direction. Now, you know it's an open bubble because it's not or equal to. When you make your other symbol, it cannot go opposite the one that you just drew. It's going to go the same direction this way. And since it's a colored in bubble, it's going to be or equal to. You'll never have an inequality that has an x in the middle like that they go different directions. What I mean by that is you'll never have a number, then something that looks like this with an x, and then something that looks this way. They'll never go opposite like that. They always go the same way. So do the easier one first and make the other one match it. B says all real numbers that are greater than or equal to 3. So there's one of your parts, greater than or equal to 3. And then it says or, so it might not overlap in that case, or less than -3. So the second one, again, I know these are graphed for you. It says greater than or equal to 3. So it's a colored in bubble and everything that way. Or less than -3. It's an open bubble because it doesn't say or equal to, so you have something that way. These or inequalities, these usually are easier for most people to understand because you write them as two separate inequalities. They're real easy to write. So your first one is whatever this is, x is something 3 right here. Now we know that that is or equal to because it's colored in, and we know it's facing this direction. So that's your first one. Your other one is this one over here. I'll just draw a little arrow. That one. We know x is something -3. We know it's less than because it's pointing that way, and it's not or equal to because it's not colored in. So when you write it, notice it's written as two separate inequalities. X is greater than or equal to 3, or x is less than -3. When you have an or inequality, you write it as two separate inequalities with the word or in between. When you have an and inequality, you have to write it with the x in the middle between the two numbers that you're bordering it with. And then C says all real numbers that are greater than or equaled to -4. So that's one thing. And there's your keyword right there, and less than or equaled to 0. And less than or equal to 0. So let's look and see how that's going to look for us. Greater than or equaled to -4. Colon in bubble, everything that direction. And less than or equal to 0. Again, 0, a colored in bubble, everything that way. So again, it's showing an overlapping area just like A was. So it's an and inequality. You write it with the x in the middle. So -4, x, 0. Now, out of these two inequalities, which one is the easier one to write right away? The 0 one, because look at the way it's written right there. If we had that in the other order, if we had it going this way, 0 is something x, is something -4, then that would be the easier one to write. But we wrote the -4 first because numerically the smaller numbers go first. So right there, determine what's going on with this situation. Look which way it's going. It's saying less than and it's or equal to because it's a colored in bubble. And make the other one match. It's going to go the same direction, and then it's also a colored in bubble. So you put yourself an or equal to for that one as well. Okay, for this one, we're going to write an inequality that represents the set of numbers and sketch its graph. So the graphs are not sketched for you. Go ahead and turn it over where you have a little room. All real numbers, you don't have to write out the sentence. All real numbers that are greater than or equal to -2 and less than 3. Take about a minute to do that one. Okay, let's take a look at this one. It says all real numbers that are greater than or equal to -2 and less than -3. This is the key word, and that's why it's italicized for you. This is going to be an overlapping one. It is easier to graph them first and write them second. It's always easier to do that. So greater than or equal to -2. You don't have to get fancy. You know you need the number -2, and you know you need the number 3. You don't need anything else to graph it. Greater than or equal to is going to be a colored in bubble. Greater than is going to be that direction. The other one says and less than 3. An open bubble because it's not or equal to and everything that direction. So that's showing what's going on. Okay, -2 is smaller than 3. X is going to be in the middle again because it's an and inequality. Which one's easier to graph? This one or the X with the 3 one? The X with the 3 one. What I mean by that question is since the variable is first, notice in this case, you look at it as two separate problems. You look at it as this problem, then you look at it the other way as this problem. That is an easier one to graph since the variable is first. So it says, in that case, it says X is less than, because look which direction the arrow is going for that one. This way, and it's an open bubble because it's not counting it, so it's not or equal to. This one is going to be the same direction. It'll never go the opposite direction, but for that one, we're going to draw or equal to underneath it. Here is your inequality. -2 is less than or equal to X, which is less than 3. Do the same thing for this one. All real numbers less than or equal to -3, or, notice it says or for this one, greater than 0. Take about a minute. Okay, it says all real numbers less than or equal to -3. So a colored in bubble because of the or equal to, less than's everything that way. Then it says or greater than 0, an open bubble because it's not or equal to everything that way. Remember, anytime you see that word or, it could be overlapping, but most of the time it's going to show going in opposite directions like that. So when you write it, it's an or inequality. These are easy for most people. These are easier. This one, you're going to write x is something 0. In fact, let me write that in red because this one is how we have it. X is something 0. The other one is going to be x is something -3. In the middle, we're going to have the word or between them because it's an or inequality. So for this one, notice you have the variable first. X is something. It's going this direction. So we're going to put that symbol. It's not or equal to. That's a blank. It's not or equal to. The other one, x is what -3? We know it's going this direction, so it's less than, and this time it is or equal to because it's a colored in bubble. And there's your inequality. Again, easier for most people, the or ones, than the and ones. Example number 2 is solving a compound inequality with and. Now, we've been used to with equations having a left side and a right side with our equal sign right in the middle. But with these and inequalities, like -27 is less than 5x minus 7 is less than 18, there's no longer a left side and a right side. Now what you have is a left side and a right side, but you also have a middle. So now you have 3 portions that you have to simplify when you undo stuff. Your goal is still the same, though. You're still trying to get x by itself, and you're still undoing your order of operations like you typically would. You undo addition and subtraction first because you go backwards. So it says 5 times x minus 7. You undo times x after you undo minus 7. So you have to add 7 to cancel it out. If you add something to one part, you have to add 7 to the other parts as well, not just the left and the right. If you do it to the middle, you have to add 7 to the left, and you have to add it to the right. At that solution step, all we did was added 7, so you don't reverse any inequality symbols. It cancels out the minus 7 part, and then -27 plus 7 gives you -20. 18 plus 7 gives you 25. Again, notice the symbols are going in the same direction. So then you have 5 times x. You undo 5 times something by dividing by 5. If you divide the middle, you need to divide the left and the right. Again, we're dividing by 5. We're not dividing by a negative number. The fact that this one is -20 is irrelevant. That doesn't make you change the symbols. It just makes that solution on the left side, -20 divided by 5, it makes it -4. 25 divided by 5 makes it 5. Notice the symbols, again, do not change. So -4 is less than x, which is less than 5. Now, here's the part that people start making mistakes with. It's easy up to that point. This is the easiest way to do this part. Graph this inequality first on your graph. So you know you need 2 numbers. You know you need the number -4 and you need the number 5. The one I have in the box says to graph less than 5. So we're going to graph everything that way. Then take this part of the inequality and reverse it to have the x come first. So it'll say x is something -4. Remember which one the big mouth eats. The big mouth in this case eats the x. So then graph it that way. It says x is greater than -4. So we have a graph that looks like that at the bottom. So the solution is all real numbers that are greater than -4 and it is an and inequality since the variable is in the middle, and less than 5. Okay, solve this one. It says -5 is less than or equal to 2x plus 3 is less than 7. Take about 1 minute. Okay, this is an and inequality since the variable is in between two inequality symbols. There's a left side, a right side, and a middle. Whatever you do to the middle, you have to do to the left and the right. Remember, you work your order of operations backwards. You look for any addition and subtraction. It says plus 3 to start. So you subtract 3. When you do it there, you have to do it to the left and the right side. -5 minus 3 is -8. That part cancels out, leaves you with 2x. 7 minus 3 is 4. All we did was subtracted 3 right there, so you do not reverse the symbols. That one stays less than or equal to, and that one stays less than. Don't add equal signs where they don't belong. Then undo the next step, multiplication and division. Divide by 2. If you do it there, do it here and here, the left and the right side. -8 divided by 2 is -4. That part cancels out and leaves you with x. 4 divided by 2 is 2. All we did was divide it by a positive number right there. You do not reverse the inequalities. They stay just like they are. Here is your inequality solved. When you graph that, you need two numbers, -4 and 2. The first one says x is less than 2, so you do everything that way. The other one, you write it backwards. X is something -4. Make sure the mouth eats the x still. Greater than or equal to -4. There is your graph.